next is we'll be looking at a table of values. So now instead of a graph, we'll be looking at the values and seeing how we could get these values into either, let's say, an amount equation or the simple interest equation. So part A asks, calculate the first differences, which is $40. You are getting $40 every year. Now, how do you know this? And let's say, why is it first differences? Well, it's always going to be linear. This is interest. It's always going up. It's never going to fall down and increase. So it's never going to be a second differences. So let's say in a communication question on a unit test, when they ask, calculate why is it always going to be a first differences, you're going to say it's a linear graph. You're earning interest and it's always going to go up. Now, B, what is the principle of the investment and how do you know? So since the principal investment is what you start out with or what you first deposited, what you're given, it's always going to be the first year. So 1,040. So they ask, how do you know it's on the first year? And if they want you to elaborate, it's what you're given. It's what first is deposited, right? Because if you deposit 0, you can't really get any interest based on what you, if you let's say you get 0, because then what you earn for interest is 0, right? So it's always going to be what you first deposited as your principal. What is the annual rate of interest? Just like the last question over the graph, we'll be taking 40 since we know that every year it's the amount's increasing by 40 or the interest is 40. So you do 40 divided by 1,040, you'd get 0.038 or a longer number. But I recommend you just round it to the nearest 100th decimal and your annual rate is 0.04. Now, let's say you're given an arithmetic sequence. Now, just to recap, an arithmetic sequence is an almost sequence, but it's adding. So let's say, for example, here, 1,040, 1,080, 120, 1,120. So you notice here that it's adding every time because when you subtract it, it's going to be 40. So that's an arithmetic sequence. So a pattern where it's adding, a common difference. So since you know that it's 1,040, that's your A, looking back at the chapter before, but we'll call it P since that's what you first start out with. And then you're wondering, oh, what about my, then this would be your plus 40. That'd be your D value or your common difference. But since it's the annual interest rate or we're focusing on chapter 7, it'd be known as R. So that would be another way for an arithmetic sequence. I just put it on this part because it's kind of like a smaller way and it kind of works in with table of values too. So let's say you're already given these, and you always have to be given 3 values. And let's say as well, I'm not sure if they'll probably give you, like, let's say the last investment and ask you to find the, when does it take the last investment. Let's say if it does, you go to the original using the amount equation and evaluate from there. So going back here, let's say when you find the, they're asking for the amount, or let's say, what if the amount triples or doubles? You'd put it here. Put your principal here, which is 1,040, and plus PRT. So then it'd be, then you just multiply this with the 40, then you get this number, and then, sorry, my apologies, not the number, but the simple interest rate, which is 0.04. Then you just evaluate it, and you get your answer for the amount, or like how long it'd take. It's kind of like the same thing as chapter 6, but chapter 7 just using different variables.